Hi everybody, so this is my first video in the series on coordinate geometry with straight line graphs. So in this question, we're told that WXYZ is a rhombus, and the diagonals WY and XZ intersect at a point N, and the coordinates of N are given as 4 and -5. And the points W and Y both lie on the line with equation 3y plus 5x equals 5. We've been asked to work out the exact coordinates of the point where the line through x and z intersects the y-axis. Okay, so the first thing we're going to do is we're going to sketch this rhombus. We're told that the diagonals through wy, which is in this diagonal here, and x to z, which I'll show in purple, intersect at the point N with 4 and -5. And we're told that the points of w and y both lie along the line 3y plus 5x equals 5. So a rhombus has a property where the diagonals intersect at a 90-degree angle. So this means the line w to y is perpendicular to the line x to z. So I'll show this on a diagram. We can use this property because we can work out the gradient of the blue line and use the negative reciprocal to find the gradient of the purple line. And it is the equation of this line which we need to find. So if we call the blue line L1 and the purple line L2, then we can work out the gradient of L1 by rearranging this equation to make y the subject. So we have 3y plus 5x equals 5. We'll move this positive 5x to the right-hand side, so therefore 3y will equal 5 minus 5x. Then we can divide both sides by 3, so y will equal 5 minus 5x over 3. And you can see that this now gives us the gradient of -5 over 3. So m is -5/3. Now we can use this gradient to work out the gradient of x to z. If we look at line L2, this gradient will be perpendicular to this one, which is the negative reciprocal, or 3/5. So now we have the gradient, and we know a point that lies along the line, which is point N. We can use the equation of a line, and this is m multiplied by x minus x1 will equal y minus y1. If you're not sure where this equation for a line comes from, I'll leave a link in the description below where you can watch how I derive this. So if we substitute in the gradient, 3/5, multiplied by x minus x1, which is the point on the line 4, will equal y minus y1, which is -5. And a minus -5 becomes a plus 5. So now we can expand out this 3 and move this division of 5 to the right hand side. And therefore we have 3x minus 12 will equal 5y plus 25. And what we're trying to find are the exact coordinates of a point where the line through x to z, from this line, intersects the y-axis. So if we tidy this up by collecting the constants together, we have 3x minus 37 will equal 5y. We divide both by 5. These will cancel, so y will equal 3x minus 37, all divided by 5. And on the y-axis, the x value is 0. So we'll substitute 0 into here. Y will equal 0 minus 37 over 5. So the coordinates will be when x is 0, and y is minus 37 over 5, or 0 and -7.4. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, missmathematics.com. There's a link in the description below. Thanks again, and take care.